Okay, I'm Jen Mendez, and I did my project on the change detection of forests in Borneo, Malaysia. I picked this particular area because the rainforests are being cut and degraded for timber, palm oil, pulp, and other materials, with their biggest threats being logging and land clearing. This started around the 1950s and has been continuing since. And then so the imagery that I used was Landsat 2, 5, and 8 for 3 different years. I picked 1979, 2004, and 2016. And so my area of focus was Sri Aman. This is towards the side of Malaysia because Borneo is being shared by Malaysia and Indonesia. This particular image is from 2016, and you can see how there's a lot of cloud cover in the area. I predicted this to be an issue, but considering it's a rainforest, it was kind of hard to find images with minimal cloud cover. So what I did was masked my images and kind of made this area my main focus. And then so for my ROIs, I had several, but I wanted to say how I had bare rock, urban, and pasture clearing, and I initially had separated them into 3 different ROIs, but as you can see through my spectral profiles, they're relatively similar, so that created a lot of confusion in my results as I ran my classifications, so I decided to combine them. And then so these are my 3 original images as they're masked, and you could see my area of focus right over here. And then to make the image a lot more visually appealing, I used a linear 5 stretch and added the true colors. As you can see, I have different colors of forests, so I had separated them into 2 different ROIs. I had Forest 1, it being this darker one, and Forest 2 being this lighter area all over here. You could also see the pasture clearings a lot more, along with this area over here being urban, kind of scattered with roads. You can also see how the colors are also relatively similar, so that is one of the reasons pretty much why I combined the 3 ROIs together. Okay, and then so for my statistics for 1979, I had water, I had my Forest 1 and Forest 2 along with clouds. I didn't include the soil pasture clearing because it was so small. For 1979, it was kind of just that small town that it was really hard for the classification to pick it up, so I just excluded it. And then so for 2004, I added water, Forest 1, Forest 2, and soil, pasture, and urban. I didn't have clouds because there was very, very, very little cloud cover. And then for 2016, I had water, Forest 1, Forest 2, soil, pasture, urban, and clouds as well because I had a lot of cloud cover. And then so I used these ROIs, these individual ROIs for these individual pictures. I didn't use one for all of my images. So I performed the maximum likelihood classification, and as you can see visually, it looks pretty accurate from 1979 and 2004. I'm sure it would be a little bit different if you would if I counted the little urban area, which would be around here, but you can't see it. And then so 2016, clearly it has a lot more of the unclassified. This is most likely due to the amount of cloud cover I had along with its cloud shade. And then in these urban areas, it was kind of the pinkish color as you saw in the previous pictures, along with the lighter green forest pasture combined. So I'm sure that created a lot of confusion as well. And so I performed the confusion matrix as well, and these are my 1979 and 2004. I had a relatively high overall accuracy, along with a producer-user accuracy, which is obviously concerning. Like I said, I'm sure this is a result to the small amount of ROIs that I had. There wasn't a lot of classifications to begin with, so it's pretty accurate. Also, I had different pixel amounts, so it was a lot easier to make bigger, more uniform pixels for the river as it was to do like urban or the pasture clearings. The classifications for like urban had to be a lot smaller than the ones for the river, so I'm sure that had a lot to do with it. and this is my confusion matrix for 2016. My overall accuracy is a lot lower. It's 92%, but I mean, still pretty good. That has a lot to do with my classified areas in this soil pasture area, which is most likely the clouds. That didn't exactly get picked up. And then so here are my change detection statistics. This is for 1979 to 2004. I have pixel percentage and area, and you can see for Forest 1, it's a 69% decrease, and for Forest 2, it's a 32% increase. Assume this is due to obviously the darker forest decreased significantly as the light green forest increased. A lot of the pasture coverage had of the lighter green in it, so I'm sure that helped a lot. Then here's a change detection map. I did two separate ones for Forest 1 and Forest 2. So this one is, for Forest 1, is the only one that had ran with color, so I'm not really sure why. But it shows like all this area that had changed from, that was once dark green that transformed into the Forest 2. You can also see the pasture clearings that had appeared. And then for this image, this is just for the Forest 2, which would be that lighter forest. There was like little change for that, but you could see all this white, which was classified as unclassified. This is most likely the pasture and soil along with roads that was built but didn't get classified. And then so this is my change detection statistics for 2004 to 2016. And then for my percentage, for Forest 1, there was a 226% increase in Forest 1, and then a 71% decrease in Forest 2. And I would imagine this is due to the fact that the darker part, which was Forest 1, I'm sure like the outer skirts that had a lot of the darker colors continued to grow. And then the Forest 2, which was a lighter green, decreased because, like I said, the Forest 1 had increased, and then a lot of the pasture clearings kind of like added into that. And so this is my change detection map, 2004 and 2016. So it shows a lot of like no change, but it's white area that was shown to be unclassified. It's probably just bigger forest pastures that formed, or in specific areas with the pastures. Some were darker soil, and others had more like vegetation, I guess, within the pasture. So I'm sure that messed with the results a little bit. And then for Forest 2, it shows a lot of the unclassified. I'm sure that has a lot to do with the like soil and vegetation patterns that I had previously mentioned. Also, you can't see in this image, but with my original image that I had on screen, if I zoomed in, you saw some gray pop up here, which showed a cloud cover, which kind of messed with it a little bit. There's some green here, or gray here too. It's kind of hard to spot. And then so I calculated the deforest area from 1979 and 2004, and then from 2004 to 2016. 1979 to 2004 had a 25 year difference. So, like through my calculations, there's a 2% decrease per year within this time frame, and then for Forest 2, there's a 1% increase per year in Forest 2. And that's also like goes with what I had mentioned in my change detection maps. The lighter green area grew bigger as the darker green vanished due to the pasture clearings. And then some for the forest change from 2004 to 2016 had a 12-year like gap area. There's an 18% increase in Forest 1 per year, and then a 6% decrease in Forest 2 per year. this also goes along with what I had mentioned earlier. If you look back at the maps, it shows how the green area kind of like grew bigger. I'm sure the forests continued to grow, and then the lime green area obviously decreased as this bigger area increased. And that basically concludes my project. If I were to make changes, I would definitely create more ROIs and spend more time with my classifications. I know they were a little biased considering I made them myself and my pixel count was a little bit off, but yeah, thank you.